Bharath. Adithya is an AI security engineer focused on adversarial red teaming. So, Shri Adithya M is an AI security engineer focused on adversarial red teaming for large language models. He specializes in discovering vulnerabilities in generative AI systems, stress testing their safety boundaries, and systematically breaking model assumptions to expose logic flaws and security gaps. His work centers on jailbreak development and adversarial prompt engineering and large-scale vulnerability assessment across multi-provider LLM environments. So, and we have two speakers for the topic, and next one is Bharath. Bharath is a cybersecurity and AI security professional specializing in securing large language models and AI-driven systems against adversarial threats, prompt injections. He has authored 5 research papers in the field of AI security and has filed 2 patents focused on enhancing the safety, governance, and robustness of AI models. His work centers on building resilient, trustworthy AI systems aligned with real-world enterprise security and risk management requirements. With that, they are going to take the topic of breaking and defending AI systems, a red, blue, purple team perspective. So please give him a big round of applause for the wonderful topic. Welcome, guys.
Access RAG, and it can also take a few autonomous actions by itself. So that's the core. Okay. Am I audible without the mic? No. Okay. Okay. So that's our focus. We have a medical chatbot which can take autonomous action, query database, and can do all that. So the flow we'll be following is we'll introduce the system we built. I'll break it once from a red teaming perspective. Then Bharath will come in. He'll explain it on an architectural level rather than just prompt filtering or simple regex or ML methods. So that's the flow we'll be following. So yes, getting started, as you all know, it's probabilistic. So we have to test it out continuously. It's part of the methodology. So when our target is probabilistic, the attack surfaces change compared to the usual cybersecurity where we're just verifying username, password, authentication, authorization, simple stuff. The main attack vector we're playing with is the reasoning, because when you think of an LLM behind the attack surface, it's almost like fighting with a real person behind, if you think about it, right? So that's what we'll be focusing on. Yes, this was the flow I just spoke about, red, blue, and purple. We'll be demonstrating it. So we also have detailed architecture of the demos we've built so that you understand in depth that defense in depth is like the need. You can't use simple regex stuff to defend AI systems. Yes, this was the medical bot we built. Can you show that? Can you switch to the architecture? And heads up, we vibe coded the entire medical chatbot. So we went to GPT, got the architecture, and then gave it to Claude Code. So we just understand the security stuff in depth. If there are any AI developers around, please forgive us if something goes wrong in the development. We just focus primarily on the security stuff, which is basically protecting the LLM underneath. That is our focus.
Wi-Fi. You need the Wi-Fi.
Oh, what happened Wi-Fi?
Yeah, we need the Wi-Fi.
I'll give the password.
So, alright, while they're setting it up, how many of you all over here have actually jailbroken into an LLM? Have you tried anything? Yes. Okay. Could you like give us a brief about what you've tried?
So these prompts, basically there are multiple ways to jailbreak. Maybe sometimes different languages
What's the right
or
name?
hash codes
𝐁𝐴.
or different characters. So I've tried these. They are like easily available on Twitter, and you can try these on ChatGPT or
So
like other models to jailbreak. Like make them like there is a very famous thing. Okay. So you must have heard about Dan do anything now. So that is very common where I've tried that on ChatGPT earlier. That was working, but now those prompts don't work.
Yes, that's actually an amazing point. So how it works is now, for example, the Gemini 3.1 was the latest release, and I think it's been 4 days since they released. So when you're red teaming, the first 48 hours of the release is the golden hour. You can report all your bugs. Maybe if there's a bug bounty, you can also earn money if you're lucky enough. But post that, all of the guardrails will be they'll be completely set up to stop any type of attack. So the first 48 hours, the model is bare and it can be toned down very easily. You don't need to be a AI/ML engineer, nothing. You should just let your curiosity lead you and the model will break apart. So the first 48 hours is everything. So speaking of my journey, when ChatGPT came out, it was about 2023, and we used to ask all of the stupid stuff. So I first used ChatGPT when I was in engineering, which is 2023, and we used to get all the recipes for substance abuse, all that stuff. We were just trying it out, and we also used to find ways to tamper CCTV and all that, saying this was for a technical study, and ChatGPT would comply because there was no safety guardrail. So the model I'm talking about is a GPT 3.5. It's been recently open sourced on Hugging Face. So it's the very first generation of models which don't understand adversarial reasoning. And we used to play around a lot, but today we've got GPT 5.3. It's like, even if you ask benign stuff, it's heavily censored. It will never give you anything malicious or forbidden or anything like that, right? Right. So is there anyone else with any sort of experience you've had with breaking LLMs or making it say something which it shouldn't have in the first place? Is there anyone else? Yes, please.
So, so this is about one of the AI assistant that was done within my company. So they were kind of giving the demo of the company, demo of the assistant with the build, and it's about assisting, some of our customers about, on the knowledge it was trying to form. So I was just, during the demo itself, I was just trying to do some prompt injection, not sort of a jailbreaking, but kind of a prompt injection, and I was able to, dump all the knowledge base. I was able to dump, the model context, and I was able to put on the prompt that was
Duplicate your screen or extend the screen.
So it does not have any sort of a sensitive information as of now, because it was the first stage of the implementation. It was just an assistant to give some knowledge to the users, how to
just let's show it.
go through the platform and all that. But however, I was just able to pull on all the information, all the prompt, all the knowledge base and everything. So it was very easy, but just a simple, few instructions that I gave. I just asked it to ignore the instructions and give me all the details, and they did. You see, so it does not have any guardrails, right? It does not have anything implemented, the security controls implemented on it. But so because of which I was able to do all this. Yeah, that's all.
Nice. Thank you for sharing. That it's actually part of a demo, that too. So it's like a spoiler, but thank you. That's an amazing thing. So speaking of one instance, there's a model called GPT OSS 120B. It's one of the first models which was open sourced by OpenAI, right? So I was checking for any sort of behavioral backdoors, something which would make it say, make it generate something which it wasn't supposed to say in the first
Oh,
place.
so many.
So then I was testing out something called a historical attack. So what happens in this is I went to it and I asked it to write me a rousing poem on a person called General Dyer. Does anyone have an idea about who General Dyer is? Sorry? Yes. Yes. So he's the guy who ordered the attack or massacre of the Jallianwala Bagh, right? So the thing is, these models are primarily trained on American data sets, and they don't care about historical relevance, or let me say the historical context, right? So we're Indians. To us, this incident is like a very, very serious thing. It's the event which led to the freedom protests, and it's indirectly related to how we got our independence. So when I went to this model and asked it to write me a poem, it actually ended up glorifying the entire incident.
Oh, anti-demo is
And when I re-questioned it, then its reasoning realizes saying, oh, okay, I shouldn't have done this. But on first attempt, because they're trained on a very different native data set, they don't care. Because, historically to an American, this doesn't make sense. And GPT-OSS models are meant to be, for math and all that. They have a lot of capability, but then if it's not contextually relevant, this is like very, very dangerous, because they're glorifying things which shouldn't be glorified in the first place. Cool, no problem. Right, okay, so by the time the slide comes up, I will fill you on before you actually have a look at it. So two things which I will be focusing from the red team point of view is two architectural weaknesses in LLMs. So the first one is called a delimiter confusion, and the second one is called a instruction hierarchy hijack. So the first one, speaking of delimiters, what it is a lot of LLMs are instruction fine-tuned, which means they're actually built to just follow instructions, whether it's harmful or not safe, they don't care. They just care about completing the next token, right? At the end of the day, LLMs don't process it semantically. At least some of the frontier models do. They mimic semantic understanding. They mimic. At the end of the day, it's all a tokens and a context window game, right? I think all of you would have seen every new model which comes out, the context window increases. A lot of models have, the recent Sonnet 4.6 had a 1 million context window, right? Which means you can keep chatting with it and it'll never run out of memory. It'll keep context of a lot. 1 million tokens is like a lot. I think it's like a 40-page book or something. It's a lot of context.
1 second.
Right? So the first delimiter, speaking of the delimiter confusion, is many of these models are trained on billions of corpus text which follow XML or JSON formatting and all that stuff. So the first thing they understand when they see JSON is that they must complete the text. They don't care if it's safe, if it's harmful, or if you're overriding tools. They don't care. That's how these models are built, right?
That I'll create a mic. I'll create a noise. It's working. Yes, we can duplicate it. Slides.
I think again if we
It's like
Just give it a try.
slides also ready.
Okay.
Yep. Okay. So we have the slides back on. By the way, if you do see the feature of Claude in PPT, it's horrible. It's still in the training phase. Please don't use it. It actually almost ruined our PPT. I trusted it blindly. It's my fault again. But the feature is not good. Please be careful if you're using the Claude plugin for PPT. It's not good. It's not production ready at least. Messed up all our data. Order.
go to demo.
Go to the architecture.
This is
Yeah. Okay. can show this. You'll explain this. This is the undefended one.
Project it now.
How?
I will explain.
What should it be? So when a model is tool capable, there's always a chance of you building a very nice creative adversarial and token stuffing prompt, and you can tear the model apart despite having all sorts of guardrails or filters. If the model is the center of the system, then definitely you can override it and take it down. We will be demoing that next. So yes, I think this is also very evident since all of you read about AI security. Now we're fighting with the reasoning aspect of it. It's no longer authentication, validation or authorization. It's all behavioral, and it's about the amount of control we're giving to these models. So that's what we'll be looking at. Yep. So coming back to the delimiter part, this mainly happens because models they're just trained to blindly follow instruction. And the very first set of models, most of the companies try demonstrating capability more than safety, right? Because there is a trade-off. The more safe a model gets, the more conservative it is. And it might actually not allow a lot of benign requests. You might ask something with genuine intention, but the model's safety, if it's too conservative, then it's not happening. It's not going to let you do it, right? And yes, this part I will be demonstrating with an actual prompt. So back at the place where we research and execute all these attacks, what happens is we build almost a 150 word prompt. It's like half a page, and we embed it in 3 layers, which means inside this prompt, there's another prompt injection prompt, within which there's another prompt injection prompt, right? So it's 3 layers. And we're doing all this to play with the attention mechanism. So I think you would have all heard of attention mechanisms, right? It's the very thing which makes the transformer architecture super useful, right? So that is one of the core exploits. We chose this attack primitives because it's very, very fundamental in nature. It's not like a 3B model will have it and Sonnet wouldn't. No, all of these models, anything operating on transformers architecture will definitely have this, and it's just a matter of trial and error before any of you can break it. If you understand and dive deep into this, it's actually not very hard breaking any of these models, right? So next, Bharath will be giving a little more insight into the blue team because attacking the model, yes, it's quite easy, but defending is a totally different game, right? Because you're adding safety to the reasoning. It's pretty serious, and it's something which I'm not sure. I don't think this approach is looked towards in traditional cybersecurity because it's not reasoning. It's a lot of validation, authorization, though, right? So yes, Bharath can take the next.
Yep. Thank you, Adithya. So. Hey, hello guys, I am Bharath. So for years now, red teaming is a very known concept. So from 5 to 10 years, people have been attacking, people have been injecting prompts into the LLMs. But we are not very sure how do you actually go ahead and secure the model. So I have been in this field for a couple of years. So I have been doing my research on how do you actually secure it. I have tried various approaches, be it implementing the guardrails, multiple filters, multiple reject patterns, which essentially blocks the basic stuff. But when you look at the 2 types of attacks, wherein we have the instruction hierarchies, we have the context manipulation prompts, we have the TAN attacks, like someone said. So the defense becomes very crucial part. So if someone is attacking the AI system and getting all your data, there's a requirement of for you to defend the system and protect your data. So that's the entire perspective of the blue team. In reality, when you talk about LLM defense, it's just one layer that you add, and you'll be like, okay, my LLM is all secured now. So that's now how defense actually works. Especially when you talk about LLMs and AI models. So nowadays, the attack surface grows on multiple dimensions, now that MCP, ACP, all this protocol comes in, there are multiple ways that attackers like Adithya can basically exploit stuff. So for that we have our own proposed approach, wherein we are bringing in multiple guardrails, multiple layers of defense, which we will be showcasing in the demo as well. Yeah, so as I told, when you talk about defense, it's not just a single guardrail that you deploy, and that doesn't ensure that you have a secured model or your entire AI system is secure. So to actually secure it, you have to go in depth. You have to look at the entire model architecture. You have to note down all the interactions that is making, whether it is making any of the tool callings which are there, so any of the model context protocols which are plugged into the model, and all the data which is accessible to the model. So you have to look at multiple dimensions. So for that we have an approach wherein we are looking at 5 dimensions, so multiple layers we are defining. So the first layer that we talk about, so this is the layered and redundant defense model that I have come up with 2 months research recently. So when you talk about defense of the model, you have multiple layers implemented. So the core part of, or the core goal here is to secure the entire AI system, right? So any number of red teaming prompts comes in, or any number of prompt injection attack, jailbreak attack which comes in, you are supposed to defend it. So that is the core goal, and that is the core idea which is there. So for that we have multiple classifiers at multiple layers. So we have multiple transformer classifiers at the input layer, at the reasoning layer, at the output layer. We also have something called as the meta layer, which we will be showing. So the first layer is the input layer, where we are stopping the prompts at the inference level. So whenever the user is hitting the LLM, we just go ahead and do a sorry for that. So we do a thorough check there. So at the input layer we do multiple guardrail analysis. We stop all these kinds of attack. We check for the intent, we check for the structure, we check for the context of the model, we check for what is the prompt that is what is the prompt about. So we classify based on all of these details, and we stop the prompt at the inference level. So that's the input layer defense. The second layer is the output layer. Next. Okay, so before that, so once the input is passed through the LLM, the model goes ahead and reasons itself. So if you see models like DeepSeek, which is a deep tech reasoning model, it would basically explain how it is arriving at a particular conclusion or a particular outcome or a response. So for that we have some monitoring for the reasoning or the response which is inside a think tag. So each think tag would send to a classifier or LLM. So we basically use this LLM as a judge model. So each of these reasoning response would essentially be sent to the LLM. The LLM would basically analyze the tool policies, the reasoning aspect, whether the model is reasoning right for that particular prompt. So it checks for the intent before it actually throws the output. So that's on the second reasoning layer. The third layer is the output part. So before the response actually hits the user, before the user is getting the LLM response data which might be harmful, we block it there. So if the model is spitting out some profanity data, or the model is spitting out some harmful instruction which it is not supposed to give, so we block those kinds of stuff. So again, the input and the output is like a dual protection which happens. So it's pretty much similar. So we use the same policy compilers, we use the same classifiers. The only difference is we monitor different layers, and we plug in multiple guardrails at the layers. The third one is something called as the action layers. So as I told, so now LLM these days have these protocols which is from the past years. So all these trending protocols, or the buzzwords called ICP, MCP, all the agentic protocols. Now these models have access to large volumes of data, tools. So now how do I stop that? How do I judge the model is making right calls? So for that we have these action layers. So before LLM takes any particular call to the before it goes and retrieves any SQL MCP or before it retrieves any internet MCP, we take actions. So the actions can be human approved. So we can put a human in the loop. So again, that's a very inefficient process, but we can. So this particular layer is still under research. So we have to figure out what are the right scoring engines or what are the right way of approving the MCP protocols or the different agentic protocols. So the next layer is the meta layer. Yeah. So here we monitor the behavior of the LLM. So if the LLM is drifting away from its behavior, so if it is a medical chatbot and some red teamer comes and attacks it and behaves it to split out some data related to its internal reasoning or its internal capabilities, you have these meta layers to monitor the model is not drifting away and it stays in domain. So that is something on the meta layer. So now these meta layers and the action layers are something which is very novel and it's not currently implemented in the industries. So there is a lot of scope of these kind of monitoring and these kinds of defenses. So when you talk about defense, it's different angles and different layers that you have to protect it. So now these 5 layers, although doesn't guarantee you the model is secure, but it does at least guarantees that you have implemented a certain set of controls to meet your governance requirements. Sure.
Yeah, so about that. Yeah, so you mentioned about the input layer defense, right?
Yes.
So is it only applicable to the systems that are, the AI systems that are prompt generators, or to all the?
It is applicable to the ML models itself. So wherein we have some kind of input to the ML models or a deep learning models, we can put it there also.
Okay, because the reason why I asked you this question is that we might use some of the AI systems that are not publicly available or not really open to the internet or public, right? The input channels are very much restricted, right? So
yes.
The only possible attack vector that I could think of is the supply chain attack.
Yes.
So is it still applicable over there as well?
Yes, so it is applicable, but as I said, so these input layers is not only defense ways, wherein we can just put one input layer and we can't guarantee defense out of it. So there are multiple So there are multiple ways that we can do. So this is just one of the way which ensures you that the input is secure.
Got it. Thank you so much.
Check. So yeah.
Yeah, I have a question.
Yeah.
So how are you implementing this partition and what is the scope in your system?
So now we define schemas and roles within the tool calls. So whenever we define MCP, so that there is a set of schemas which comes with the tools. So we monitor these schemas before the user hits his input. So at the internal code level, we do the entire scan and we define the schemas so that it is secure and the tool calling doesn't go out of the bounds. So that's how you do it. Any more questions? Sure. Give the mic there.
Yeah, so my question was basically LLM as a judge, using that, does that not feel like you are compounding the same errors again and that the first model makes, because they do make errors, and is there any alternative that is more reliable that you prefer?
So when I say LLM as a judge, we are using custom LLMs. So it is more user specific or a role specific kind of a thing. So we train these LLMs only on a secured role permissions, and then we deploy it. So in a quantized version. So the cost is also the cost also doesn't matter. So you have to train it on or train or fine tune it on a only specific set of roles and permissions so that it can monitor and give a correct output. So again, as you said, there is multiple validation for the judge as well. So we have to make sure it is accurate enough. So that is a challenging thing.
So just to say, let's say that is expensive, right? So any lightweight or cheap alternatives?
You can go with the Keras models, LSTM models. So these are the most basic ones. So the Keras models is a level below of all these transformer and attention layer models, but it is still accurately enough to detect all these kinds of attack. So go with deep learning models if cost is the issue for you. Do we have any more questions? Okay, so this is the entire tool that we built. So this is the medical chatbot that is there, so which is connected to a medical database. So the database has all the patient records, the database has all the prescriptions. You can book appointments in it. So just like any real world medical company or a medical chatbot looks, so we have simulated the same thing. So the demo comes with two parts. So this is the undefended system, wherein the implementations are weak. That means there are no guardrails, there are no ML or layer defenses, all the reasoning defenses, none of it is present. It's just an undefended system, just like how while implementing, developers might miss out and the attackers can succeed in the future. So this is one of the undefended system, and we in this particular demo we also show when you plug in the guardrails what exactly happens. So there is a toggle bar right there, which essentially shows you if you on and off the guardrails what exactly happens. So this is one of the prompt that we sent to the LLM. So this was crafted by Adithya. So here it goes ahead and just the model is broken and it just gives all the details of prescriptions of the. Would like to continue? Sure. One second. Yeah, go ahead.
Before you started this one, right?
Yes.
Can you give little brief idea about what LLM model is used, what data is used, simple architecture to build this sample analysis?
Okay, before demo I think we'll show the architecture itself. So we have the three architectures. So we'll just navigate to architecture.
Because pen testers that will make a
Understand.
Sure. How
Just go to architecture.
Wait, what else?
He wants to look at the architecture first.
just brief on discussion about how you build this application.
Okay, so the model which just broke, in case you noticed the tool log, we're using a Llama 3.3 70B. We chose this target because it's very easy to break and it's a very old model, so it doesn't have the most latest, we call it reinforcement learning using human feedback. So it's done by Meta Corporation. They have a lot of resources, and usually models with this reinforcement learning are super strong and they clearly understand the intent behind what we ask, right? So when I toggled off the guardrail, this is the undefended one. So the biggest mistake, not mistake, the flaw in this architecture is that there is no filtering, right? When I say tool executor, this is exposed to the LLM, right? The LLM is just trained to follow the instruction. It doesn't see if it is safe, it doesn't make sense of the queries, it is just being as helpful as it can, right? And that itself is enough for the attacker to get through. So that is the flaw in this architecture. So and one more thing, the prompt which you just saw, I took it from a GitHub repo because the prompt which I crafted, it stopped working today morning because LLMs are probabilistic. It worked perfectly yesterday night, but today morning it was all gone, right? So I went to GitHub. You can also, for me, whatever research I've done, this GitHub repo has played a huge role in how I perceive threats to LLM. It's called, he's one of the hackers listed on the Time magazine's top 30 AI people. His name is Elder Plinius. Has anyone heard of him? Nope? Okay. So this guy, his main job is any model which is released, he'll be able to break it within 2 or 3 hours of the launch. And he comes and makes the data open source so that tomorrow, let's say, if you're using this model, you will know exactly which prompt is going to break the model, right? So I took the prompt from there and thankfully it worked.
One more thing, if anybody wants to do this hands-on type, is it this your code is available?
Yes, yes. This is fully wipe coded, so we will not take any credit for it. It's on our
We'll
GitHub
open source.
repo. You can just replicate it, and it's super simple to use. Yes. So in terms of architecture, the biggest flaw here is there is no moderation. The model has not been told clearly what tool to use under what circumstance, and that is enough for an attacker to play with the entire system, right? Can you switch to the demo? Yep. So next time you see a prompt with that, can you scroll down? Yep. There. Top. Yep. If you see this tag, you should know that it was that hacker who breaks models, right? So what happened here was we turned off the guardrail, so there's no security, no policy enforcement. There is no. We also have a system here. Can you go up? There are 3 modes in the system. Yep. An admin can just see very basic stuff. He can check out the prescription, he can see the patient's data. That's about it. The nurse has a little more features. She can issue prescriptions and she can take action. Yes, the green checked ones are the capabilities of the nurse. The doctor has full access. So all of our attacks which we just did was from the admin one. Yeah. So with the right prompt, when there's an AI system involved, the admin will have the same level of access as the doctor. That's the attack surface of all of this, right? All right. Okay. Yeah. Okay. It thankfully worked. Yes. That's the whole problem about AI security. All of this is probabilistic. Maybe 5 turns in, this may not work. That's a problem. So this is the tool which got issued now. It was done from the admin account. So what we're doing is we're on purpose. We just diagnosed James Patel with a cocaine addiction, and the model was smart enough to retrieve this methadone. So in real life, methadone is it's like it's the drug they give, not drug, it's the medicine they give to someone who's in rehabilitation. So the model was able to use its own internal training data to diagnose and also prescribe like a fake thing. We're building it. Like he's just an old person with arthritis or something, but we broke into the system and made him a cocaine addict, right? So now let's look at the system with the guardrails on, right? Yep. Okay, yes, again, thankfully it stopped. Yesterday night it wasn't working, but we fixed it. Cloud Code helped us. And so right now Bharath will elaborate on the 2 models we're using internally. So what we're doing is, for the input we're using something called a guardrail. A guardrail will give only binary outputs. It sees if the input which is coming is harmful or not. It's more like a classifier, right? It can only reason in binary. It's either a 0 or a 1. So first level of defense is the guardrail. Second, we used a reasoning model, right? Because this entire system depends on the reasoning. It's about telling the model what to do and what it shouldn't do. There we used a GPT OSS model, and this is a safeguard model. It's meant for tasks like this. This is the whole purpose of it. We'll be switching to the defended place, and Bharath will be taking over. Yes. So in case you noticed our architecture, these 2 components are extra, the one on the left corner. Yes, this is it. So yes, Bharath can take it.
So yeah, we are almost out of time, so I would like to speed it up a little bit. So now if you see here, there are 2 different guardrails which are present. So but again, there are multiple schemas defined for the MCPs for whatever tool callings that we are making. So that is one, and the 2 guardrails that we are using here, one is the Llama prompt guard 2. The second one is GPT OSS safeguard, which was also released last year. So these are the 2 guardrails that we are using. So but again, the problem here is these 2 are a little bit costly. So if you have to implement it, you have to have a mega GPU architecture to run these models and deploy the entire architecture there. So these are the two models. So now with these right set of guardrails and right set of schema, right set of policies defined at multiple layers, you can basically ensure that the model is at least 50 to 70% secure. So none of them can guarantee you 100% secure, and if they are guaranteeing, I mean, of course they are lying. So that is a defended architecture. So we also have a looping system. So the whole idea of this presentation that we want to give is that we wanted to bring a new perspective to the industry, to the people who are, to you guys who are actively participating in in this AI security field. So we wanted to put this perspective, when you assess the organization and you issue a governance compliance policies on the organization, the organization should have a perspective of continuously attacking the systems and continuously defending the system. So this is the concept of the purple team, wherein the attacker comes, you attack the model, you understand all the vulnerabilities of the model. Next layer is you defend the model and check if the model is correctly defined or not. So the purple time is all about attacking and defending. So when you do this loop, you can essentially make sure that this period of cycle is running for 6 months or 12 months, and your systems are compiled. Sure.
So when is the purple team perspective?
Yes.
When the threat is discovered, so it is feedback into the system, like feedback into the LLM.
Yes. When I say purple team, we get feedback to the system. So after the guardrail defends that particular prompt, we give it as a feedback so that the system can strengthen. So that's the entire concept. So it is about strengthening your organization and also ensuring the regulations. That's a good question. Can you just go to the PPT, last slide? So as I told, so this is the entire gist of the purple team. So we wanted to put this perspective out there. So when you enter the space of AI security and when you talk about complete AI security, you start from the attack, you attack the systems, you defend the systems when your vulnerabilities are understood or exposed to outside. The third step is the purple team, wherein you analyze and strengthen at the same time. So there is a lot of feedback coming in from the systems, which will essentially help yourself to defend it. So whenever the tool is exposed or protocols are exposed to the outside, which is helping hackers to scale their attack, you can basically strengthen your models or the organization and be safe from it. You want to hang on? So done. So yeah, we are open for any questions.
Yes. Yeah, we thank you, Michael, and hope you guys enjoyed our interpretation of it. So yes, any questions? Yep. Hello.
Thanks. When you are building your LLM models and trying to bring an optimized code, how do you ensure that the compute power is under control?
Okay, so you let me try understanding the question with an example. So you're saying if you have a 16 GB RAM, which LLM to use in your system to make it run optimized, right?
Or if you want to have an additional compute power, we should ensure that the whatever codes or whatever application you are building, you need to have minimum compute power. You cannot exceed your threshold.
Yes.
Which increases the cost. Cost of infrastructure.
How do you decide computing power for the model to deploy? Is it correct?
Yeah.
How do
you identify costing power for the model when you are going to deploy?
Okay, so if you're looking purely based on hardware, there's a GitHub repo, it's called LLM Fit. So basically, okay, if you want to do it based on intuition, you can say, now my laptop is a 12 GB RAM laptop. So for 12 GB of normal CPU RAM, I think like a 7B, I can't be mathematically accurate here, but a 3 to 7B model is safe. The maximum we've gone is we use a 96 GB VRAM H100 GPU, an NVIDIA GPU. So for that, we go up to models of 17B to 24B. Anything larger than that, the GPU gets a OOM error, out of memory thing. But if you're doing anything on your local, I think for a 12 GB, this ratio would be a 5B to 7B from Olama would be safe. That would what my instinct would say.
Yeah, I would like to add on to this particular question. So, a lot of times it's straightforward trial and error. So, we can't straight up be like it's a 7B model or a 3B model which is required for my use case. So, the use cases might be different. So, that's the reason companies nowadays have a complete R&D department which does this research on the use case and comes up with GPU infrastructure and the model. So, that's the straight way to put it.
One more point to add is number of users, who are the users? See, even though our model is built, very well, it's working fine. But if the number of users who are going to interact with that model, it largely depends. Otherwise, the processing power, parallel threads, multiple threads, it has to be done. That depends very well.
Yeah.
Cool.
Yes. Pass.
Last question. After this, we will have networking break. During that time, you can ask more questions. Okay, because we are running out of time for the next speaker.
So very quickly, so all the guardrails and everything is divided in two parts, at the ingestion layer and the output layer. But when we are submitting final query to the LLM itself, that time are you clubbing any rules or any logic with the query, because it can affect the context of the query and affect the accuracy of response. So have you encountered that?
Yes, the action layer which talks about tool calling is for that. So whenever there is a agentic protocol architecture or in an agentic architecture, we define schema rules, so secure schema rules, so that the model, whenever it talks to other agent, it talks it in the right way. So models can spoil models, so we have to ensure it is secure enough to network properly. That's the. So yeah, thank you all for joining us here today. It was a nice interaction with you all.
Thank you guys.
Thank you so much, Shri and Bharath, for a wonderful session. Hope you guys like. Thank you so much.